All right, in this video, I want to go through two examples of these proof sequences where we just have to write out the reasons and the steps and focusing on how to find the correct rule. So say the first one we want to do is we wish to prove this statement right here. Now I'm going to zoom in a bit to just that. So we kind of, but the instructions are to just fill in these proof steps. So we want to fill in these proof steps. Now the first thing to notice is that we have some hypothesis, apologies, we have some hypothesis implies some conclusion. The only thing we can take to be what's considered a given is the hypothesis. So you can't say that you're given the conclusion just because it was stated in the problem. So the first thing we always do is we list our givens. So we list the hypothesis. Sometimes we'll have more than one hypothesis, but in this case we just have one hypothesis, and that's what's written in line 1, so we would consider this just a given. And now at this point we want to take the given and we want to manipulate it using our rules to get our result. Now things can get a bit harder as you move forward in the proof because there's more things to work with, but in the first step you only have one choice. It must have come from step 1. So what suggestions I might give you is to look for the differences in line 1 to line 2. So let's point out some of the differences that we have here. So we have a couple differences. One of them is the fact that we don't have a not to begin with. So we pick up a not, and then our implication symbol essentially changes over to an R. And that's really the only two things that are happening here is we have a not that's coming in, and then it turns into an or. So the thing I would suggest if you're having trouble figuring out what rule this came from, specifically look first at the logical connectives. Those are going to be your big tips. So we want to look for a rule that includes a implication and an or statement. So an implication and an or statement. Let's forget about the not for a second. Let's just look at the implication and the or symbol. So let's go over to our rules and let's say, okay, which one of these have or statements or implications? So conjunction doesn't, so that one definitely doesn't work. Modus ponens has an implication now, and so does modus tollens. Now they don't have or statements, but let's keep them around for a second. Simplification does not have an implication or an or. Addition has an or but not an implication, but let's keep it in the running for now, just in case. Double negation doesn't have anything that we need. Implication has both, so that looks like a really decent one. Now all of the rest of these do include ors, but don't include any implications. So now let's start narrowing it down a little bit, because we do have these ones that have just one or the other. But we do need to narrow it down for more than that, because here we have both. So we must have went from something with an implication to an or. So we not only need one or the other, but we do in fact need both. So that essentially gets rid of absolutely every option except for implication. Implication is the only rule that has both an implication and an or. So that looks like it's probably going to be our best bet. Now let's triple check that that's actually what happened here. We shouldn't just assume, we should double check that this is actually what happened in the proof. Well, if we look back at the proof, we can say we start with some A implies B. And then we have A and B showing up in the other piece, but we have not A or B. So let's see, does our implication rule take us from some A implies B to some not A or B? Yes, that's exactly what our rule tells us. So this first step is implication on line 1. So we have implication from line 1. Now, after doing your first step, again, it can get a bit more complicated because it might have come from step 2, it might have come from step 1. Personal suggestion, always look at the step above first. If you can't figure out how the step above gets to your next step, then you might have to expand your horizon a bit, if you will. But most of the time, it will come from the rule directly above it. So let's look at the rule directly above it, the line directly above it, I should say. And let's start noting those differences again. So what differences do we see here? Well, there's no not in the beginning anymore, but there's knots on the inside. This symbol changes. Now the back completely stays the same. So the only thing we seem to be affecting here is the thing before the or in the original statement, I will say. So we're essentially looking for a rule that deals with negations. And what it looks like it's happening here is it looks like it's that negation coming inside the parentheses. So we kind of want to look for something that might tell us how to deal with a negation when we have it outside of a set of parentheses. Well, let's start looking at our rules. None of our inference rules really look like they're going to help. Let me keep double negation in mind, but everything else doesn't really seem like it's going to help. Those last few don't include negations at all. Now, so the ones that really deal with just negations are either double negation or De Morgan's. Well, we have something more complicated than what's going on in double negation, so we must be in De Morgan's case now. So let's double check that that's actually what's happening here. Well, in De Morgan, we have two options. Either we start with an and or we start with an or. And we started with an and, so let's make sure that it follows the correct pattern it should. Now, this one's nicer because it does actually, it looks exactly like De Morgan's. It looks like not P and Q. So that's kind of nice because it's easier to check. So we need to make sure we have not P or Q. And that is exactly what we have in line 3. So it must have been the case that this was a case of De Morgan's law. De Morgan's law on line 2. So now we move on to try to figure out where line 4 came from. Well, again, I would suggest always just starting by looking at line 3 and seeing if it can come from line 3. So let's start looking at some differences again. Well, our ors stayed the same, and so did, our variables. Our variables haven't changed at all. The only thing that has changed is the position of the parentheses. That's the only thing that's changed here. So let's go over to our list of rules and see which one kind of deals with moving parentheses. So none of our inference rules seem like they're going to hold in that case. And the only one of the equivalence rules that looks like it moves parentheses, you might say it's between either associativity or distributive property. Let me just, go for the sake of thinking too many could be possibly the option here. But if you note in the distributive property, we have to have different signs. We have an and an or in each case. So that one definitely is out. So the only one that's kind of left that looks like it deals with moving parentheses around is associativity. And so here, that's exactly what we have going on. And it's a little bit more complicated than the rule states because we have some knots floating around. But essentially what we have is we have some, A or B or C, and we're just moving the position of the parentheses. So line 4 would have come from the associativity rule. On line 3. So we've got one last step, so now we have to figure out how we get to line 5. So again, first thing you might want to look at is just look at line 4 and see if you can get it from line 4. What are the differences we're noting between lines 4 and 5? Well, this negation essentially goes away. That or becomes an implication, but notice that this last piece stays exactly the same. So again, if you're not used to figuring out these laws easily, look at that pattern. So you have a not that's disappearing, and more importantly, let's focus on the fact that we went from an or to an implication. So which one of our rules deals with implications and ors? The only one that deals with both of those things is our implication rule. It deals with both an implication and an or. So let's triple check that the implication rule held here. Well, we started with some A or B. So if I write it as A or B, that should have become not A implies B. So now looking at this rule, I put the, nope, sorry, I thought it was going to be a different color. Looking at this rule back here, I technically didn't have the not here, but you can always kind of pull out a not. It's almost like a negative. If I say positive 3, you could write that as negative 3, right? So I could always pull a negative out for any reason I need to. So I can call not P A and then consider not A to be just regular P. So my implication rule is holding here. So since that's a held implication rule, and if it's harder to see that way, why don't I write it this way too? So if it was harder to see that way, why don't I write not A and keep that not around? So not A or B, A implies B. So maybe if I keep the not out of the renaming, maybe it's a bit easier to see. So that means that my last step must have come from the implication rule on line 4. Whenever you see whenever you see an implication and then it turns into an or, you should think it's the implication rule. That one's going to come up a lot. So that's some tips that I think might be helpful, hopefully, in doing these kind of proof sequence questions. Let's look at one more that's a tiny bit more involved and has a little bit, a few more steps. So let's look at this one here. So what I want to prove is given right here. Now in this one, I actually have 2 givens because I have to take everything that's essentially to the left of the double arrow, if you will. So that means this first line is a given and this second line is a given. Now that can also make things a bit more complicated because now you have more choices. It might not have come just from the line above it. It might have come from either line 1 or line 2, or maybe some strange combination of the two when we include things like conjunction and the modus rules. So let's start looking here. So we have this line 3. Well, for starters, which line does that look more like, line 1 or line 2? It looks more like line 1. So let's take a look first and see possibly if we used line 1 to get line 3. But what are some of the differences between line 1 and line 3? Well, in line 1, we do have an or R in the back, and we have the same thing in line 3. So these are equivalent. They didn't change at all. But then here in the front, our not P changed into a regular P, and our Q changed into a not Q. And this sign in the middle changed. And the not, there's a not that appears outside. So look at those differences and look over at our rules and see possibly which rules take care of those differences. Which rule here kind of moves my negatives around and also changes the sign in the middle? Well, that would be De Morgan's laws. That's the only one that really works with moving negatives around, if you will. All the other ones with negatives just kind of have the negatives in the rule. It's not manipulating the negatives in any way. De Morgan's law is the only one that works with kind of manipulating and moving around the negatives, the negations, if you will. So let's double check to see if De Morgan's held here. Well, the or R, sorry, my screen changed on my screen. There we go. The or R in the back was not affected, so we don't need to worry about that. But let's look and see what we had. So we had, let's say, some not A or B, and we ended up with A or not B. And then, well, in this case, I guess the renaming is a little silly because they're just singular variables. So let's just hold with this. Now, this doesn't look exactly like De Morgan's laws because we have a negation inside the parenthesis already. But here's how you can probably think about De Morgan's law. It might be helpful. You can kind of think of De Morgan's law as factoring out a negative when it comes to algebra. So say I wrote down something like negative 3 plus 6. I could rewrite that as negative 3 minus 6, negative the quantity 3 minus 6. Whereas also, if I went the other way, if I had originally written, maybe something slightly different, 7 plus 2, then I could distribute that through as negative 7 minus 2. And if you can follow the distribution of these negatives or the factoring out of the negative, that's kind of what's happening with De Morgan's. Not exactly, because we're working with logical, symbols here, but if it's helpful, that is kind of what's happening. So even though we start with a negation inside the parenthesis, if you think about pulling a negative out, a negation out of both of these pieces, if I pull the negation out of not P, I just end up with P. Now, if I pull a negation out of, if you'll allow me to say, a positive Q, again, it's not really that we're working with positive and negative numbers here, but if you will allow me to draw that kind of parallel, if we have this quote unquote positive Q, what happens when I pull a negation out of it? I'm going to end up with the negation of Q. So De Morgan's law is holding here, and it's essentially because we're pulling out the negation. We're going from the right side to the left side of De Morgan's rule. So this was De Morgan's that held here. So it was on De Morgan's on line 1. Well, now how do we get line 4? So again, we have a lot more things to work with here, but let's go back to the idea of, can we get it just from the step above? So let's just take a look at the step above. That's always a good first place to start. What are our differences? Well, the negation in the front goes away. The second piece stays the same. Our sign changes from an or to an implies. So our logical connective changes from an or to an implies, but then the R stays the same. So the main thing that's happening here is that change in logical connective from an or to an implies, and then we also have this not piece that's going on. Well, once again, if you have an or and an implies, it's most likely going to be an implication rule. Does that hold here? Yes, it does, because we essentially start, renaming here might be a bit more helpful. If we think of this as a not A or B, that would become an A implies B, which is exactly our implication rule. So here, from 3 to 4, we used implication on line 3. Now this next step is where things get a bit more intricate and a bit more involved, I should say. We have not P or not Q. If I look at line 4, if I just start by looking at the line above it, what's the differences that are going on? Well, I have a not that's getting picked up. So I'm picking up a not somehow. This piece stays the same, but then my implies R is gone. Now, is there a rule that takes me from an implication to only one piece of the implication, like that gets rid of half of my implication? And if I start looking at my rules here, the only thing that kind of starts with an implication and ends with something without any extra logical connectives than what I started with and doesn't have the implication is one of my modus rules. So it looks like maybe we can use one of these modus rules here. Now, it might be hard to see which one. So let's kind of come off to the side and look again at kind of the idea of what we need to use each rule and what we would get. So what we have to start with is we have this line 4. We have this something implies R. And so let's look at what we would need and what we would get from each one of those rules. So ponens versus tollens. So also let's view this as some A implies B. So in ponens, we need P. So we'd essentially need A. We need the hypothesis. So we would need P or not Q. And what we get is we get the conclusion. So we would get B in this case. So we would get R out of it. Well, what do we need and what do we get from Tollens? Well, from Tollens, we need a not whatever the conclusion is. So in this case, we'd need a not B, so not R. And what do we get from Tollens? Well, from Tollens, we get not the hypothesis. We get the negation of the hypothesis. So we'd get not A, which would be not P or not Q. So looking at that idea of what we would need and what we would get from either of those modus rules, does it seem like we know which one we might have used? Well, I notice that exactly the line I'm looking for is right here in the modus tollens get column, if you will. Well, that means I would have needed to have not R somewhere in my proof. I have it in step 2. So I have what I need, and what I get is exactly the line I'm trying to figure out how I got. So it does seem that this line follows from modus tollens on lines 4 and lines 2. So also remember that tollens and ponens need 2 lines. You can't use modus tollens or modus ponens on just one line. So if you want to try to say modus tollens on line 3, you should already know that something's wrong, because modus tollens and modus ponens need 2 lines to be able to use them. And if it helps to come off to the side and ask yourself what you would need and what you would get in terms of the actual context of the proof you're looking at, go ahead and do that. So let's keep going. We're almost done this one. So now we want to figure out how we got not P and not Q. So as always, let's start with just trying to look at the step above. Well, what are the differences here? Well, the main difference is that the sign changes. And then we have a lot of negations moving around here. Well, what's the rule that tells us how to move around negations? Well, we said that that's De Morgan's law. That's really the only one that deals with manipulating negations. And also remember that De Morgan's law flips the sign in the middle. So that sounds like a really, really good choice. Let's triple check that that's how this would work. If we used De Morgan's on line 5, we would essentially be distributing the negation, if you will. We'd get not P, flip the sign, but then we have to negate something that's already negated, but we would just put the extra negation there. Well, that's exactly line 6. So this is exactly De Morgan's law. On line 5. Well, then what about from line 6 to line 7? Well, let's look up at line 6 and see if we could get there from just the step above. Well, what are the differences? Not P stays the same, and symbol stays the same. But now we go from a not Q to just a regular old Q. Well, what's the rule that kind of deals with not? Because that seems to be the thing that disappears. Well, the only rule that deals with having more than one negation is double negation. So here we use double negation on 6. So hopefully going through those two in that manner, this took a bit longer than I was expecting, so sorry for the length, but hopefully that made sense of taking a look at what you have, looking for the pattern more than the exact correct symbols. You're not looking for P implies Q, you're looking for something implies something else. So you kind of want to look at the pattern that's going on in these rules. And specifically, the main thing to focus on is the logical connectives. So if you see that you have an or and it changes to an implies, it's probably implication. If you have 2 nots and suddenly you don't, it's probably double negation. If you have a negation that seems to be manipulated through some parentheses, it's probably De Morgan's. If you have parentheses and they're the only thing that's moving, probably associative. So you can kind of start narrowing rule options down based off of the logical connectives that are going on and the differences between the line you have and the line you want. And so really, sometimes you have to step back, and if it helps to rename these things, if it helps to rename the entire P or not Q piece you're trying to work with as A and focus on it as some kind of like not A or B, and then having just singular variables to work with, if that renaming helps, you can totally do that off to the side. But hopefully that helps a bit with these types of questions. Of course, doing full out proofs, it's a bit more complicated because you don't necessarily know where you're trying to go. But hopefully for these ones from 1.2, where we're just filling out the reasons and the steps, hopefully it's helped to make that a bit easier to understand.